So the question here is, find the condition for the line y equals mx plus c to be a tangent to the hyperbola x squared on a squared minus y squared on b squared equals 1. Okay, so if y equals mx plus c is a tangent, what we'll start by doing is we'll substitute that into our formula. Y is equal to mx plus c. So let's try and solve these two things simultaneously. We'll solve by substitution. So I'm going to substitute y equals mx plus c into the equation for the hyperbola, and so we'll get x squared on a squared minus mx plus c squared on b squared equals 1. And now we've got some algebra ahead. So here goes. Okay, so this is what we end up with. We end up with a quadratic equation. It's a pretty horrible looking quadratic equation, and we have to make sense of this. Out of this, we need to come up with a condition for this original line y equals mx plus c to be a tangent. So what we really want is some constraint on that involves a and b, m and c. That'll be what we're after. So where do we go from here? Well, the trick here is to bring in a little bit of quadratic theory. If this line y equals mx plus c is to be a tangent, right, that means that it touches this hyperbola at one point only, which means that this quadratic that we've got can only have one solution. Right? It only the line touches at one point only, and this is the condition. This quadratic gives us, if we were to solve this quadratic, it would give us the points of intersection. There is only one point of intersection, so there is only one solution to this quadratic. If there's only one solution to this quadratic, that means that the discriminant of this quadratic is equal to 0. Let's write that down. Discriminant equals 0. So that gives us the condition that we're after. That's what we're going to work towards from here. We want to work out the discriminant. We'll make that discriminant equal to 0, and that'll give us a condition for all of these bits and pieces, the A, B, M, and the C. And that's what we'll end up with. So here goes. Let's just move all of this stuff over to the side first. So the discriminant is equal to b squared minus 4ac, but we need to be careful here because b squared minus 4ac is, we're using b's in two different contexts. So b squared, b is the coefficient of x, and so that is minus 2mca squared. When we square that, we're going to get 4m squared c squared a to the fourth. That's b squared minus 4ac. So minus 4 times the coefficient of x squared, which is b squared minus a squared m squared, times c, which is minus a squared b squared plus c squared. So that all looks quite ugly. Here's some algebra, which I will do quickly. Now, this will equal 0 only if, see, a and b can't equal 0, so the only way that this expression is going to equal 0 is if b squared plus c squared minus a squared m squared equals 0. That's the condition that we're after. And so therefore, for this line y equals mx plus c to be a tangent, it'll only be a tangent if c squared is equal to a squared m squared minus b squared. And that is the end of the question. That gives us the condition for c, the constant term in y equals mx plus c, the gradient of that line, and the values a and b, which are tied up with the equation of the hyperbola. And that's what we end up with after some pretty horrible algebra, but that's what you get in this unit, lots of horrible algebra. And that's the end.